YC Mathematics and Physics, University Calculus, Lecture 20, How to do limit problems. We start with an example. Limit of x squared plus 4x. What is this equal to when x goes to 2? Goes to 2 means when x approaches 2, very close to the value 2. This problem is quite easy because what you do is just to do substitution. You substitute the value 2 into x, and that's all you need to do. You substitute 2 into x, and you get 4 plus 8, and of course it is 12. So 12 is our result. So the steps are very simple. Just do substitution. This step is substitute 2 into x, and you get the result. It's very simple. Let's have another example. I have a fraction. The numerator is x squared minus 9. The denominator x plus 2. And the limit is when x approaches 2. Again, we substitute. We substitute the number 2 into the variable x. And that's how we need to do. That's all we need to do. Substitute 2 into x. So this is the result. Substitute 2 into x, and you get this. And then you just do the calculation. So the numerator is 2 squared minus 9. It is 4 minus 9, and it is negative 5. The denominator is 2 plus 2, which is 4. Therefore, the final result is negative 5 over 4. So, the whole thing is just to do substitution. Again, we have a fraction, and we want to do the limit. This question is slightly different from the last two examples, because when you do substitution, you substitute 2 into x. Then look at the denominator, what you get. 2 minus 2 is 0. But remember, you cannot divide anything by 0. So it is not that you substitute. We must do something else. What is the something else? Look at the numerator. The numerator is in the form of a squared minus b squared. That can be factored into a plus b times a minus b. So this is what we do. We factor the numerator. So what we do? Factor the numerator. There you see x minus 2 can be cancelled. You cancel x minus 2, so what you are left with is just x plus 2. Then at this time, at this step, you can do substitution. Now you do substitution, the answer is 4. So 4 is your final result. This is slightly different from the 3 examples before. Here, x goes to infinity. What is infinity? Infinity is a number which is very, very large. So, this x becomes a very large number. Very large number. Large number, large number, and large number. But look at the power. This x goes to power 3, and this x only goes to power 2. If you substitute a large number into the first term and second term, which term is bigger? Of course, the first term is bigger because it goes to cube, power 3. So this will be much larger than this one. And of course, it's much larger than 4. And this last term here, cube here, so this is very large. And this is not so large. And this is even not so large. So, what do? We divide both the numerator and the denominator by the highest power of x. In this case, it's x cubed. So we divide the numerator by x cubed, and we divide the denominator by x cubed. This is a result of dividing the numerator by x cubed and the denominator by x cubed. Okay? Now, the next step is to do the limit. The limit is x is a very, very large number. When x becomes a very, very large number, then 3 over x is 3 divided by a very large number. So this is almost 0, right? It becomes 0, almost 0. 4 over a very, very large number cubed, it becomes almost 0. Similarly, this becomes almost 0, this becomes almost 0. Therefore, if you take the limit x goes to infinity, all these become 0. Therefore, we are left with 2 over 5. Oh, no, not 2 over 5. I'm sorry. This is 0, this is 0, 0 here, 0 here. It's what we are left with is 2 divided by -7. So this is my final answer. And this is how you do it. Divide by x to the power 3. What I want to mention here, you can do it in a much shorter way. I give you a shortcut. We have mentioned that when x becomes very, very large, on the top, this part is very large. At the bottom, this is very large. So you can neglect those terms which are small compared with the large term. You just neglect it. So all you need to do is to keep the largest term at the top and keep the largest term at the bottom. This is the shortcut. So I have this thing can be written as limit you keep only the largest term at the top and at the bottom. So the largest term at the top is this. The largest term at the bottom is this. So I keep the largest term at the top and the largest term at the bottom. This is a shortcut. Alright? Then the x cubed at the top and x cubed at the bottom cancels out. Therefore, this is cancels, then do the limit. It cancels is 2 over negative 7. This is a shortcut. Let me repeat. When your limit is x goes to infinity, then you keep only the largest term and then simplify the result. You got the final result very, very quickly. So this is today's lecture, how to do limit problems. And sometimes we just do direct substitution. But sometimes before we do direct substitution, we need to simplify something. So to simplify, one of the ways is to factor. So when you factor the top, or factor the bottom, or factor both, and sometimes you can cancel something. So after you cancel something, the expression becomes simpler. And then you do direct substitution. And sometimes the limit is for x goes to infinity. And in this case, you can keep only the largest term, and the result is very simple. I mean, the process is very simple. And this is our shortcut. Thank you for watching. I'll see you next lesson. Oh, by the way, I will give you some practice problems, and I will post it on YouTube. The practice problem is about limit. Thank you. Goodbye.